you can have read-only fields in a class in C#. This is how you declare them. You add the word read-only before the data type, and then you type in the field name. As you can see here, the first read-only field I've declared here is actually also initialized to this value, while this second field is not initialized here, instead initialized in the constructor. Then I have another read-only field here, which is the value of a pi. This field is a static field, so it is accessible without being dependent on an instant of that class. So as you can see here, when I try and change the value of read-only field 1, I cannot do that because this is saying that it's a read-only field. It cannot be assigned except in the constructor. And as you can see here, same thing for the static read-only field. For static fields, you do not need an object. You do not need to create an instance of that class. Instead, you can just use the class name itself to access the value stored there. So if I get rid of this and if I run this, and as you can see here, I am using the class name in the pi, while these are actually instances. So here, obj1 and obj2 are two separate instances of my class. And as you can see, once the value is set, these read-only values cannot be changed. And here's the output, as you can see here. Notice that for read-only field 1, it was actually not passed in the constructor. Instead, it was provided with a default value right here in line where the declaration of that field happened. So yes, so read-only fields could be used for something that you do not want to change after an object have been initialized and created. So here, for example, when I did create my class and I provided a value in the constructor, that value is now fixed through the lifetime of the class, so it cannot be changed. So this will be useful in certain situations. And same with the static property here. As you can see, since it was a read-only property, the value of pi, so you do not want that value to change. So you can use a read-only class for this purpose. So a difference between a static variable and a normal instance variable in C# is that static variables are shared by all instances, while the instance variables are not. They are individuals to the instances that are created or the objects that are created. So as you can see here, I've got a constructor here for this static variable. This constructor is used to assign here the name to this variable, but it also increases the count by 1 every time an object is created from this class. So every time an instance is created. Here I've got a static method, which basically returns the count variable, which is also a static variable. So this is shared by all instances. And then here I've got the display method, which is instance method. So you can see it's an instant method. And here you return the name of this variable, which is instance variable. So it's not shared across all objects created from this class. The benefit of this is by having this count function as being static, you can count how many objects have been created of this class. So how many instances have been created. So here, as you can see, I'm creating 2 objects. So I'm creating C1, C2, and I'm calling them object 1, object 2. So when you create this and then you call the instance method, you will get the name according to that instance or that version of the object that you're creating or the variable here. So that's known as the instance variable. But when you do a get count is a static method, and you notice that you're not calling it on an individual instance or the variables here, you're actually calling it on the class type. So the counter class type, and it will return to you the count of how many objects have been created of this class. Now, the reason you get the count of the objects is because we are here increasing this variable, static variable every time. And this variable is shared across all instances. So here, it's shared by this one and that one. But the way you access the static variable is not via this object, but you access it via the counter.getCount static function that we had. Because it's a private variable, so it's not accessible in any other way. So here, I've just carried it private. So if I run this, and you can see that we will get 2 outputs. So here, we've got object 1, object 2, and the name. And then we've got total counter for these objects. So we've got 2. So you can see here that this is getting the count returned from here. And this is shared across the 2 objects. So here, when you create 2 objects, it's just increasing this by 1 every time. Initially, it was 0. Then when you create the first object, it increases it to 1. And then when you do it again, increases it to 2. And that's the important property of the static variable, which is it's shared across all instances of the class. So I hope this makes sense. So you can use the static variables in a class to count things or store things that are accessible to all within a class. So something that is shared across the class and all the instances. Classes can have auto-implemented properties in C#. So as you can see here, I've declared a property called name, and this is an auto-implemented property. This means you just declare it with the shorthand get and set, And what it will do is it will automatically generate a backing field. A backing field is basically a private variable that holds the same data type. So in this instance, it will create an anonymous field that you can't access in any other way. The compiler will generate that field for you behind the scenes. So this is known as an auto-implemented property, and it's for simple things like where you don't need to do any validation and you're simply setting the values of the field. So name is being basically set here and get there. So this doesn't need any other validation. But with other private properties such as age, then you want to add some validation rules. So this is called a backing field. And this is only accessible through this public property access. And this is done with the get and the set. So here with the get simply returns the age. Now notice this age is lowercase, while this one is in uppercase. So we can see here that I have validation for the set. So here the user cannot enter a negative age. So this is just checking if the value passed by the user is greater than 0. If it is, then set it to the value of the variable age, which is the lowercase age there. Otherwise, it will throw an exception. So here, when I've got another field here called read-only property. And what this will do is it doesn't have a setter. So this is read-only. There's no way to set this info field, but it will output the following. It will type the name and the age, and it will also return the values of name and age. Now notice down here, when we then access this, so we create a new person class and we set their name using the auto-implemented property, which we saw before. So this is over here when you've got get and set auto-implemented, and that's automatically generating the backing field. And then when you come down here, I'm setting the age, and the age is using the property with validation. So here you can see age begins with a capital A. So this will then go down here. It will check the value. If it's greater than 0, then it will set the age variable here to that value. But if not, it will throw age cannot be negative error. So as you can see here, then you can access the read-only property here as well. So this is just needing nowhere to write back to it. So this will simply output the information here, name and age in that format. And of course, you can access the age and name separately, so they don't have to be in this info property that's being passed back. So if I run this, and as you can see, there you've got name Alice and age 25, or you can print them separately like here. So you can access it via this, or you can access it via this. Notice it's the capital A here for age and name here, which was the auto-implemented property here. So that's just accessing the get setter here. So yeah, just remember in terms of auto-implemented properties, will automatically get a backing field like this, but it's anonymous, so you can't access. The compiler generates it for you. So this is for simple things like that. But if you want to do any custom validation, make sure you have a backing field and then a public way to get and set that field. So here, that's why we've got this validation on the age and the error if the age is different. And here I've just set the age to -25. So hopefully when I run this, you will see that we will get an error. So as you can see here, I've put an unhandled exception, age cannot be negative. So this is thrown by our validation rule. In C#, you can loop through a list of items. So I have a list here called fruits, and I want to loop through and print out the fruit names here. And also I've added 2 more fruits here. And as you can see, when I want to print that list out, what I can do is just use the list variable name and then do for each and then pass it a method. Now this method is passed as a delegate. So what you need to understand is within this for each here, just naming the method to run every time for each of the fruit. You can use any method that takes in a single parameter of type string. So here console.writeLine does do that, because as you can see here, writeLine normally takes in a string. But what happened behind the scene is C# will convert this delegate into an action, and that action will be performed. So here it will be like this. For each take an action, action takes the parameter of t. That t in this case is a string, because this contains string, and then this variable name will be executed, which actually is the function name here. So this will get executed for each element passed to it. This is the easier way to do iteration through list. The old-fashioned way of doing it would be to do this, which is write for each loop in here. And then what you can do is you can write out explicitly, say console.writeLine, and you can see the fruit name, which will be a string. So this is the old way of doing it, and it's the longest syntax, but here's the smarter way of doing it. So I have a list here, and this list has the items apple, banana, cherry. And let's say I add another banana in here. So I have now 2 bananas in this list. Down here, you can remove all instances of the banana by simply using the anonymous function. So you use the parameter f, that f is equal to banana. If it is, then remove all instances of it. So if we run this and see what we get, and as you can see, I originally had 2 bananas here. Then that banana got removed and I'm just left with apple, mango, and orange. So just remember to use remove all and then anonymous function, passing in the parameter and then comparing that parameter, giving